Okay, we're on section 11.4. It's logarithmic functions. A logarithmic function is a way of writing an exponential function that aids in solving for the x being in the exponent form. We gotta at first learn how to go back and forth between exponential and logarithmic. All right, so let's say I have 3 squared is equal to 9. If I want to take that and I want to write it in logarithmic form, the base number here is the same as the base number here. So it's the log of base 3, and you write it a little bit lower than log. This part right here is going to be what it's equal to. So the exponent is what a logarithmic function is equal to. And this over here is going to be put right there. So in other words, your base stays the same. Your exponent is what a logarithmic function is equal to, and what your exponential function is equal to is going to go beside your log. So this is red. The log of base 3 of 9 is equal to 2. Now hopefully this is just review. Hopefully you had this in Algebra 2, but sometimes you don't get there, so I'm kind of teaching it like it's brand new. Okay, so let's work on a couple more where we go back and forth between the two. This one, let's start as a logarithmic and change it to an exponential. All right, so the base number here is the same as the base number over here. So we got the 125. What's equal, what the logarithmic function is equal to, is the power over here. So this is 125 raised to the 2/3 power, and it's going to be equal to your 25. Okay, hopefully that makes sense. Go ahead and try this one. So pause the video and then come back to it. All right, the base number is the same, so it's 8 raised to the 1/3 power is equal to 2. Now you know, or hopefully you remember, that 1/3 is the cube root of 8. So the cube root of 8 is 2. This would be 125 raised to the 2nd power, but then you're going to take the cube root of that number, and that's going to give you 25. All right, let's go the other way. Let's start with exponential and go to logarithms. Okay, we already did one like this, but go ahead and try this one and make sure that you can get it from exponential to logarithmic form. Right, the base number is the same, so it's the log of base 4. The 3 is going to be what it's equal to, and the answer there is going to go right there. Okay, try this one. Remember that -3 means that that's actually 1/3 cubed. Logarithmic, so base of 3 of 1/27 is equal to -3. Now, it's going to become very important that you can do that in order to be able to solve your problems. Okay, I think, let me put a couple more up here and let's make sure that you can do them. I'm going to put one going one way and one going the other way. All right, convert that to logarithmic, and then take this logarithmic and convert it to your exponential. Well, wait a minute, I did that wrong, hold on. All right, now take that, convert it to logarithmic, take this and convert it back, okay? All right, this becomes the log of base 27 of 3 is equal to 1/3, and this would be 2 to the negative third power is equal to 1/3. All right, so that's just rewriting back and forth between logarithmic and exponential. So let's work on solving some of these. Those are just rearranging them. Okay, to solve something, they might give you this. Okay, and they say solve log of base 7 of 1/49. Well, let that equal x. We're trying to find out what x is, so I'm trying to find out what the answer is. So now turn around and write it in exponential form. 7 raised to the x power is 1/49. Well, what I want to try and do is I want to match up the bases here. So I have 7 to the x power. I can write this as a base of 7 if I do 7 to the negative 2 power, because it's underneath 1, and 49 is 7 squared. So you can see the bases match up, so the exponents would have to match up. So x is equal to negative 2. All right, let's try another one. All right, solve that. Go ahead and let your unknown be over there. So I have 5 to the x power is equal to 625. I want to make the base numbers the same. So I've got 5 to the x power, and this is going to equal 5. I forgot my 1. 5 to the negative 4th power. So therefore, x is equal to negative 4. All right, now there's math to be done on logarithmic form, just like any other form, and there's certain rules or certain properties that you have to learn to do it. Like multiplication property is written as addition property. So if I have the log of base b of mn, it's the same as log of base b of m plus log of base b of n. So another way, if I put some numbers in there, let me find another marker. The log of base 3 of 9x would equal the log of base 3 of 9 plus the log of base 3 of x. Okay? That's your first property. That's multiplication property. This is a division property. If I have division, it's the same as subtraction with a log. So if I'm going to actually, well, I didn't write that all out. Hold on. Give you the form. So that's the same as the log of base b of m minus the log of base b of n. So done out. An example might be log of base 4 of 33 over 2 can be written as the log of 4 of 33 minus the log of base 4 of 2. Okay. Another property, let's say I have an exponent. Log of base b of m raised to the x power. Okay, the x comes to the front, so it's x times the log of base b of m. Again, I'm hoping this is just review for you, but I don't know. Here's an example. Hopefully you can still see it at the bottom of the thing. Let's say I have the log of base 2 is 7 squared. I can rewrite this as 2 times the log of base 2 of 7. Okay? All right, and then there's one other concept that we need to cover before we actually do problems here. So all of that stuff has to be learned. But here's the other thing. If I have a log of base b of m and it's equal to a log of base b of n, then my logarithms more or less cancel out. It's like I'm dividing by the log of base b, and I can say m is equal to n. An example of that would be like, let's say I have a log of base 8 of 3x minus 4 equals the log of base 8 of 5x plus 2. Now, in order to do this, I can only have a log on both sides. I can't have two different logs, okay? And I have to just have one term, which I do because it's a parenthesis after the log. Those logarithms must match up. It would have to be the log of base 8 on both sides. If I have a log of base 8 on one side and a log of base 7 on the other side, I can't cancel it out. So those two go away. So I just say 3x minus 4 is equal to 5x plus 2. I'm going to subtract here, get a negative 2x. Subtract there, get, or actually I'm going to add there and get a 6. So x is equal to, and I don't think I did that one, 2. Yeah, that would be 6. So x would equal, x would equal negative 3. Now, especially if it's a negative, I've got to bring it back up and make sure it works in the equation. So if I put it in here, I would have a negative 3 times 3, which is a negative 9, minus 4, which is a negative 13. So basically I'm saying 8 raised to some power is going to give me a negative 13. That is impossible. There is nothing I can put there that's going to change a positive to a negative. If I try a negative number, all that's going to do is place it underneath 1. It's not going to change it to a negative. So a lot of times the negative answer does not work, but you have to plug it back in and see if what you are telling it is that the 8 is going to change to a negative number with some power. Okay? I don't have another answer besides that, so that one doesn't work, so it's empty set. So, all right, let's do another one. This is actually solving using these properties. All right, I can work this out. This I know is a power, so if I took the cube root of 64, that would give me 4. So this becomes the log of base p of 4 is equal to 1/2. Well, this is set up so that I can change it to exponential form to solve for it. P to the 1/2 power is equal to 4. If I want to get rid of that 1/2, so I just have p, I can raise it to the 2/1. What I do to one side, I have to do the other side. It's like squaring it. If you will, you have the square root of p is equal to 4, so you square it to get rid of the square root. So that leaves me with p is equal to 16. And that's my answer. All right. Continuing on. You'll notice you have a logarithm on both sides. They're both 4, so I'm going to divide and I'm going to get rid of that. So 2x plus 11 is equal to 5x minus 4. When I subtract, I get a negative 3x. When I subtract there, I get a negative 15. So x is equal to 5. Okay? Alright, here's another problem. Alright, notice this is addition. And when we said addition, it's the same as multiplication. So I can rewrite this as log of base 11 times x plus 1 is equal to the log of base 11 of 6. I'm going to have to do distributive property here. So I have the log of base 11 of x squared plus x is equal to the log of base 11 of 6. I can get rid of the log of base 11, so I have x squared plus x equals 6. I'm going to bring everything to one side. And I'm going to factor, I think I better do it over here so you can still see it. So x plus 3 and x minus 2. And that's going to give me x is equal to negative 3 and x is equal to positive 2. Well, notice what I'm saying here. I'm saying the log of base 11 of something is going to give me negative 3. So 11 raised to some power is going to equal negative 3. So I'm trying to change a positive to a negative by just an exponent. It doesn't work. So that leaves me with my answer of x is equal to 2. All right, I'm going to have you do a couple more of these, and then I'll give you your homework on this. All right, do that problem, and then we better leave that so I have enough space. So do that, pause the video, and then come back to it. All right, the log of 10 goes away, so I'm left with 2x plus 5 is equal to 5x minus 4. So I have negative 3x is equal to negative 9, x is equal to 3. That's what you should get as an answer for that one. Let's try one more. Okay, remember that subtraction is the same as division. So this is the log of base 3 of 4x plus 5 over 3 minus 2x is equal to 2. Well, I don't have a logarithm on that side, so it can't cancel it out. So I have to write this in terms of exponential functions. So 3 raised to the second power is equal to 4x plus 5 over 3 minus 2x. Well, I'm going to multiply both sides by 3 minus 2x to get rid of it off the bottom. This is equal to 9, so this gives me 9 times 3, or 27. 9 times negative 2, or negative 18x. That cancels out, so I have 4x plus 5. I continue, bring that over. I have a negative 22x when I bring the 4 over. And when I bring the 5 over, I have a negative 22. So I'm going to get x is equal to 1. All right, hopefully you're understanding. If you're not, and you get to a problem that you can't do, just text me that problem. I'll help you on that problem so you can go on and do the rest of your homework. Always know I'm just a text away. All right, homework, page 723. 20 through 52 all. Now, some of this is just real easy, so I think that'll be a good sufficient amount to get you to cover the bases on it. Okay?